Nines. Okay, so this is sort of part two from last week. Last week we just gave you straightforward questions for week five, learning how to solve different problems, no word problems. This week we're concentrating on word problems. Okay, so what I've done is kind of the same strategy I've done before. I'm giving you similar problems from your homework. I noticed that in this week's homework, I've given you page 327 and 328. Just looking at it here on my other monitor, question 13, 14, 15, 18, 19, 20, 21, 22. Okay, let's start with question 13. This is the classic money question. All right, there are many different types of money questions. Believe it or not, this is a basic one because you can get questions that talk about three different coins instead of two different coins. There's lots of ways of asking these money questions, but let's just deal with the way question 13 is asking it. So it says a jar contains 76 more pennies than nickels. Well, okay, so here's what I've done. Obviously, I'm not going to solve this question for you, but I will do a similar problem. So let's start with my question. A jar contains 15 more dimes than quarters. The total value of the dimes equals the total value of the quarters. How many quarters are there? Okay. And what's the total value of all the coins in the jar? There's two questions here. So what are you going to start doing? You got to start to do like, what did I notice? Well, you notice the information they're giving you. You've got 15 more dimes. Okay, so what kind of coins are we talking about? Dimes or quarters? Yeah, I've changed it from pennies and nickels, but it's going to be the same strategy, okay? The total value of the dimes equals the total value of the quarters. So part of your reading comprehension that I talked to you about is water down the problem. In other words, start wrapping your head around what is this problem asking you, and think of the easiest numbers you could work with. So let me show you what I mean. Let's just say the jar had $2. Okay, I'm just ignoring the 15 more for now. Okay, I'm just saying, actually, let's just start with $1. Okay, $1. Let's say the jar had $1. All right. Okay. Well, if you have dimes and quarters, what could that look like? Okay. Well, you could have 1 quarter, you could have 2 quarters, you could have 3 quarters, and you could have 4 quarters. Now, here's the deal. Okay. Again, I'm just trying to get you to approach this logically. If the jar has 1 quarter, that's 25 cents. And there's no amount of dimes in the world that can give you $1 even. So it's not possible that that jar could have 1 quarter, okay? Similar reason for 3 quarters, okay? Because 3 quarters equals 75 cents. There's no rounded or whole number amount of dimes that can give you $1, okay? 2 dimes would give you 95 cents because 2 dimes is 20 cents. 3 dimes would give you $1.05. So this is not a possibility. I suppose you could have 4 quarters, but that adds up to $1. And the question kind of is implying there are dimes. So there really can't be 4 quarters. Okay. So there must be 2 quarters here. All right. And that would be 50 cents. And that would be dimes. Dimes would mean you need 5 dimes to make the other 50 cents. So this little quick example, even before I do my example, was just to wrap your head around. I want you to try and think of these questions as logically as possible, okay? Start asking your question, what if? What if there was 1 quarter? What if there was 1 dime, right? You could start by doing a simple T-chart. I think I was doing this today with the 9 twos. You could just start doing you could start doing a T-chart. And by the way, guess and check would be very, very legitimate way of solving this. Okay. So what if you were to just randomly guess this? If there was 1 quarter, let's go to my actual problem now. There's supposed to be 15 more dimes. If there's 1 quarter, then that must mean there must be 16 dimes. And if there were 2 quarters, there must be 15 more, 17. And this pattern goes on and on. This looks like your classic T-chart. It doesn't have to be, X and Y. It could be dimes and quarters. So what I'm trying to establish here, guys, is you've got to connect the information. You've got to establish a relationship between your coins. And whether your coins, okay, are pennies and nickels or dimes and quarters, you've got to find a way of connecting the info. Okay? So one of the classic ways of doing this, these coin problems, is to do a chart. So I'm going to save you the painful trouble of watching me try to construct a chart. I've already pre-constructed one for you. Okay? You may want to do something very similar. I would suggest you really ought to consider doing a chart for coin questions. Okay? So let's start populating. Let's just start writing in this chart. Okay? So what do we have? We have dimes, okay, and we have quarters. I hope you're okay with abbreviations. Start very simply. You start talking about the types of coins. We have dimes and we have quarters. Well, what's the value of a dime? It's 10 cents. And how do we write 10 cents as a decimal? 0.10. Now, some people actually write 10, like don't write dollars, they write it in terms of cents. I don't prefer doing that. I prefer to stick with the decimals, okay? And I think there's a small advantage later on if you get these questions again in high school, but I'm not going to get into that right now. So how many dimes do we have? Now we reach the issue. We have 15 more dimes and quarters. That doesn't tell us how many dimes we have. That just simply tells us the relationship of dimes to quarters. So I don't know how many dimes I have, and I don't know the amount of quarters. I just know the connection of dimes to quarters. I know the relationship of dimes to quarters, okay? In other words, there's 15 more of these suckers. There's 15 more dimes. So I'll give you a hint. Whenever you're setting up a connection or relationship between how many of each coin you have, and you think, Mr. Smith, I don't know how many dimes, I don't know how many quarters, it sounds like this is unsolvable. But you have the relationship. Ooh, that's supposed to be an R. Let's try that again. My apologies. Okay, you have the relationship between them, and that is key because it's the relationship that allows you to have one variable. So, in other words, instead of actually having two legitimate questions and going, I don't know the amount of dimes, I don't know the amount of quarters, what do I do? Whatever you're relating to, in other words, it's dimes to quarters. I suggest you write this phrase out, okay? I'm going to circle it in light pink, okay? I would suggest you write this out like a little phrase, whatever you have. If it's pennies, nickels, dimes, quarters, loonies, it doesn't matter. Try to write out like a little 3-word phrase of saying dimes to quarters, pennies to nickels, nickels to loonies, loonies to quarter, whatever it is, dimes to quarters. And whatever the last coin is, that is what you want your X to be. You can set the question up in many different ways, but this is what I recommend. And I'm trying to keep it very simple. Because we're relating dimes to quarters, we're going to give the X. So in other words, let X equal the number of quarters. Okay, I'm going to use a lot of abbreviations here because I need the room. Let X equal the number of quarters. Okay, now guess what? I don't know the amount of dimes, but I do know this. I can set up this binomial relationship. Look at this. I know that whatever the amount of quarters is, I have 15 more dimes. So if X were to equal 1, right, that means I have 16 dimes. If I were to have 2 quarters, then this expression also works because now I'll have 2 plus 15 equals 17. So it's the relationship that is key there, grade 9s. Draw the connection between the relationship between the two different types of coins, okay? So I'll just figure that out again. Okay, so now you've got to glue these two together. If I have 1 dime, it's 10 cents. If I have 2 dimes, 20 cents. If I have 6 dimes, 60 cents. You notice how it's always the value of one of the dimes times how many. In other words, we have a multiplication relationship. Let's glue this together. So with this expression, you're going to need the distributive property. It's 10 cents per dime. How many dimes do we have? I don't know, but I do know it's 15 more than the quarters. So this is the key setup, right? You start off with really simple stuff like labels, dimes, quarters, what are the value, identify your variable, and now the total value is how many dimes do you have? This is how many, right? And you're going to times it by the worth of each coin. In other words, a 10-cent coin is worth 10 cents. All right, over here, this is a much simpler expression because it ends up being a monomial. Okay? It ends up being a monomial. All right, there's no distributive property because this expression here is simple. This expression is a little bit more complex. All right, so you need the distributive property here. Okay, you need the distributive property here. Okay, all right. So let's put it together now. Let's switch over to purple. And I'll just dial this the right amount. Okay. So all together, what are we looking at here? How are we going to connect everything together? Okay, to connect everything together, look what it says. The total value of the dimes equals. So these two things are supposed to be equal. So again, I'm just looking away from what I've built there, even if it looks complicated. Think of it from a simple point of view. They're supposed to have an equal amount. Now, the total value is supposed to equal the total value. So if I have 10 dimes, I better have 4 quarters, because if I have 10 dimes, that's $1. If I have 4 quarters, that's $1. The total value of each coin is supposed to be the same. Now, I know that doesn't fit with what the problem says. I'm supposed to have 15 more dimes. If I have 10 dimes and 4 quarters, that's only 6 more dimes. So I know that there's more than $2 in this jar, right? Because if there was $1 worth of dimes and $1 worth of quarters, that'd be a total of $2. So my thinking didn't work there. It's not a solution, but I'm trying to connect the relationship. How do we connect the expressions? So, in other words, your left side, which is going to talk about dimes in this case, its value is equal to the right side, okay? And this time we've got quarters. So the two expressions must be equal to each other. So 10 cents a dime, okay? Just writing this all out. So that's the value. I've got a pile of dimes here. I don't know how much it's worth, but I've got an expression to solve. And I've got a pile of quarters. I don't know how many quarters, but I do know that the value of the quarters equals the value of the dimes, okay? I'm just going to pause briefly and get my face out of the way and create some room here, okay? I'll be right back. Okay, we're back. I just wanted to erase all that stuff over there, and now I'm dragging my head, which is kind of a surreal thing to do. And let's keep on with the solving, all right? So I've got 10 cents. So what have I got here? I've got an equation, in other words. I was able to build the equation off the information. All right, so the value of the dimes is supposed to equal to the quarters, and this simple symbolic representation really can be given the numbers. Each dime is worth 10 cents. This expression is how many do I have? I don't know how many I have, but I do know one thing. I've got 15 more dimes than quarters. I know a quarter is worth a quarter. It's worth 25 cents, right? So 25 times the amount of quarters. If x is equal to 1, I've obviously got 25 cents worth of quarters. If x is equal to 2, 50. If x is equal, and so on, okay? Let's solve this now. Let's distribute. Now we've got a workable equation. So 10.1 times x is 0.10x. You notice I'm leaving this 0 in because it's money, and I don't know, it makes me feel better. 0.1 times 15 is 1.5, okay? Now, over here we've got 0.25x. There's really no simplifying there to do. The only thing I did on this equation, guys, is that I chose to use the distributive property to bust open these brackets. All right. Since I've got an x on this side, an expression with x, and I've got an expression with here, and this constant is already sort of lonesome and by itself, I might as well just bring the variable over to the right side. So in other words, I'm going to subtract both sides by 0.10x. Okay, so that has, of course, the incredibly predictable and wonderful effect of that zeroes out. And what are we left with? 1.5 is equal to, well, 25 hundredths minus 10 hundredths equals 0.15x. Okay? Sorry, I forgot the subtraction sign there. Now, divide both sides by your coefficient. You always just make a carbon copy clone of your coefficient, all right? Divide both sides by 0.15. And look what happens here. You get 1.5 just in case you don't believe me. I know the answer, but because I set up this problem. 1.5 divided by 0.15 is equal to 10. Okay? So 10 must be equal to x. What did we just solve? All right? No, it's not the secret of the Sphinx. I say that because it's coin problems. I love coin problems. I know you guys are going to think, oh my gosh, this is a lot of work. Yeah, it is a lot of work. I don't know what to say to you. Okay, we got 10 quarters. And therefore, we must have 25 dimes. Okay? And let's check this. Let's just see if this works. Because checking it really will be answering question B. Okay? Let's check. If we have 25 dimes, okay, let me just draw a little T-chart here again. So let's just, okay, whoops. All right. Let's do a little T-chart here. Okay. All right. So look at the dimes. Here's the quarters. If I supposedly have 25 dimes, all right, and they're worth 10 cents, don't I have really $2.50? And over here on the other side, in contrast, I only have 10 quarters. But 10 quarters, remember, obviously quarters are worth more. They're worth 25 cents. Look what I have. I have $2.50. Sorry for the wackadoodle too. I have $2.50. Okay. Well, this seems to check out here because it says the total value of the dimes is supposed to equal the total value of the quarters. So I've got $2.50 worth of dimes. This pile of dimes is $2.50. There's 25 of them. I've got 10 quarters, and they're worth $2.50. And then all together, right? You gotta be clever about this, right? All together. Let me do this color and let me do it really big. Okay, a little thicker. So all together, don't we have a total of $5 in the jar? Right? If $2.50 is made up from the dimes, another $2.50 is made up of the quarters, don't we have a total of $5? That's the answer to B. Okay? Whew. Yeah, there's a lot of work. Okay? I think the real key is sorting information, organizing information, make a chart, make the expression, make the connections and the relationships, build an equation, solve the equation. Look at all those steps. I know, you're so happy. Okay, we'll talk to you for the next question. Thanks, grade 9s. Have a good one.